Hey everyone, this is meteorologist Ben Price at the National Weather Service in Springfield, and welcome back to another Weather Unlocked session. This is video 41, and we're going to be talking about hurricanes today. Hurricanes have been a big topic recently, with there being a few devastating storms this year, 2024, and with hurricane season coming to an end now at the end of October. This two-part video series will focus on everything about hurricanes, including their formation, structure, climatology, hazards, and the forecast and products meteorologists make for them. This first part will focus on the formation of hurricanes, so let's get started. We're going to start off with how we start off almost every Weather Unlocked by simply defining what hurricanes are. Now, hurricanes are a specific class of tropical cyclones. Now, I'll get into what I mean by a specific class soon. Hurricanes and tropical cyclones are warm core low pressure systems that develop over the tropical or subtropical waters, have an organized circulation, and have sustained wind speeds of at least 74 miles per hour. Now, what is meant by the term warm core low pressure system? Well, there are two main types of low pressure systems that impact the United States. These are either cold core or warm core. Cold core systems are what the United States usually experience. These systems are tied to the jet stream. Because of this, the counterclockwise rotation around them pulls down cold air from the Arctic and pulls out warm air from the tropics, often creating warm and cold fronts. These systems bring your snowstorms, thunderstorms, long-lived rainstorms, cold blasts, pretty much any active weather. On the other hand, warm core systems do not have fronts associated with them, as they usually form in the tropics, which is obviously made of entirely warm and moist air. So let's demonstrate how this works. Imagine these black lines are lines of constant pressure. So for example, the bottom line might be 1,000 millibars, and the top line might be lower at 700 millibars. So just showing you going up in the atmosphere. The warm, moist air above the tropical waters rise and condense into clouds. The process of condensation actually releases more heat in the air column. Since this warmer air is less dense than the air around it, the pressure within the storm lowers. This creates the low pressure at the center of the storm. The low pressure promotes more cloud and storm formation, which lowers the pressure more. And the cycle continues with the storm getting stronger until it becomes a hurricane. It'll keep getting stronger until something stops it, and we'll talk about that later. Now, remember that hurricanes are a class of tropical cyclones. That's because, well, one, it's called a tropical depression or storm if it's too weak to be a hurricane, but also two, they're called different names depending on where they are from. These are the major areas where tropical cyclones form. This is where the air is most warm and moist and the tropical waters are warmest. Storms that form in the northwestern Pacific are called typhoons, and they can form all year long. Tropical cyclones that form in the southern Indian Ocean are called, well, tropical cyclones, and these are more likely to form in late October through May. Storms that form in the northern Indian Ocean are called severe cyclonic storms and are most likely to develop from April to December. Those that form in the southwestern Pacific and eastern Indian Oceans are called severe tropical cyclones. These generally occur in late October through May. Then, lastly, tropical cyclones are only called hurricanes if they form in the Atlantic or the East Pacific Oceans. Hurricane season here is from late May to late November. Notice how there's a distinct lack of tropical cyclone formation along the equator. That is because something called the Coriolis force, the force that makes storms spin, is near zero there. So tropical cyclones simply can't form there as they won't gain any spin. Also, if a storm were to try to cross the equator, it would be torn apart because there's no Coriolis force there. So, there are three main ingredients that are needed for hurricanes to form. Now, I kind of mentioned the first two previously. This is, of course, warm ocean waters and relatively moist air. These two variables need to be relatively deep, both through the ocean and into the atmosphere, so that enough energy is there to sustain a hurricane. The last ingredient is a sneaky one, though. It's weak wind shear. In other words, not a lot of changing speeds or direction with winds through the height of the atmosphere. Now, for those of you that follow along to our Weather Unlocked series or know a thing or two about severe weather yourself, you know that wind shear is essential to continental severe thunderstorms. So why is it detrimental to hurricanes? Well, first, let's briefly recap how wind shear helps continental thunderstorms. So let's say there's a thunderstorm initially, and that thunderstorm has an updraft. If there was no wind shear or wind speeds were pretty constant with height, the rain from that storm would fall back into that updraft and basically kill the thunderstorm off as it cuts off the warm inflow. Now, in the presence of wind shear, the changing wind speed and direction with height essentially tilts that updraft so that the rain falls away from it and does not cut off the warm air inflow of the updraft. This allows thunderstorms to organize, live longer, and produce severe hazards. This tilting and organization is important because these thunderstorms form in cold core systems, which means generally cold air is behind the formation of the storms. So in order to live for a long time, they need unrestricted access to warm, moist air. However, in the tropics where hurricanes form, there isn't really any cold air to deal with. Remember, these are warm core systems, and recalling from how warm core systems are formed, the low pressure is stacked in the vertical. So, in order to stay vertical, there needs to be little change in wind speed or direction with height. If there is wind shear, this would shear away those vertically stacked low pressure areas and basically tear the system apart. So, weak wind shear or a lack of wind shear is needed for hurricanes to form and sustain themselves. And then a further note on warm ocean waters. It's almost widely known that hurricane season peaks in late August through mid-October, but this is basically fall. So what gives? Well, this is when ocean temperatures are actually the warmest, since water retains heat better than air. If you want a more in-depth explanation of why this is, you can watch the Lake Effect Snow Weather Unlocked video, and there we explain this process a lot better. But for this video, all you need to know basically is that water retains heat more than the air. So there is a lag time between the hottest air temperatures and the warmest ocean temperatures as the heat builds up in the ocean over time. This puts the warmest waters in the late summer into early fall, and as such, hurricane season generally peaks in this time frame. Okay, so we talked about the 3 ingredients needed for hurricanes, but warm waters, moist air, and weak wind shear doesn't just magically make hurricanes form, because then there'd be hurricanes a lot, because warm waters, moist air, and weak wind shear happens a lot over the oceans. So there's a secret 4th ingredient that's needed to basically kick off the formation of thunderstorms. These are what are called disturbances, and there's 3 main kinds that can kickstart tropical cyclone formation. There could be a tropical upper tropospheric trough, or a TUT, an old frontal boundary, or an African easterly wave or disturbance line. African easterly waves are basically waves of thunderstorms that move east to west with the trade winds off of Africa. These waves continue to move east due to a weather pattern over the North Atlantic called the Azores High or Bermuda High. This is basically a persistent large-scale high-pressure system across the North Atlantic. Clockwise flow around the high steers these waves to the east. This is why hurricanes tend to move west to east and then curve north once they reach the US. The clockwise flow at the western edge of the Azores High steers the storms northward. Anyways, if these waves move into an area with warm ocean waters, moist air, and weak wind shear, thunderstorm development will gradually increase until the warm core process creates a tropical system and eventually a hurricane. Now, the next way is a TUT. Remember, the cold core systems we talked about before? Well, TUTs are basically remnants of these troughs that make it over into the tropics, whereas they aren't cold core anymore. A TUT can be seen by the brown dashed line here. The disturbance and lift associated with these troughs can force thunderstorms. And again, if these storms move into an area with the 3 ingredients we talked about before, warm ocean, moist air, and weak wind shear, they could develop into a hurricane. Now the last method is an old frontal boundary. A front that drops over the ocean is an area of spin and lift. The cold air coming down from the north and warm air lifting up from the south creates lift and spin and creates thunderstorm development, which again, if it moves into a favorable area, could become a hurricane. Now, the frontal boundary has to be old because fronts in full force are generally a source of wind shear. So generally, tropical systems don't form along strong frontal boundaries over the ocean. The case shown here actually became a tropical system that impacted the East Coast this year, 2024. So, as I have been hammering home, if one of these disturbances moves over an area with warm waters, moist air, and weak wind shear, thunderstorm development occurs and/or intensifies. Thunderstorm development lowers the air pressure, remember our warm core process. The low pressure creates counterclockwise flow around the low pressure system. And remember, this only occurs when the Coriolis force is present, which isn't true at the equator. Then the warm core process continues, creating more thunderstorms, lowering the pressure more, and increasing the wind speed and organization. A tropical depression is designated when the system has a defined circulation with wind speeds less than 38 miles per hour. A tropical storm is designated when wind speeds increase to between 39 and 73 miles per hour. And then a hurricane is finally designated when wind speeds exceed 74 miles per hour. Remember, we mentioned before that this warm core positive feedback process will always continue. As long as there is warm water, moist air, and weak wind shear, the hurricane will continue to get stronger and more organized. The process halts when the storm encounters an area that is missing any combination of the three ingredients. Going over cold or cooler waters, or going over land where there's no water, means no more fuel and the storm dies. Dry air entering the system would inhibit further development and the storm weakens and dies. And if the storm moves into an area with stronger wind shear, it will tear the storm apart and it dies. So that's everything about how hurricanes form and their life cycle. So that's everything about how hurricanes form and their life cycle. The next part will discuss the structure of hurricanes, their hazards, and the forecast products used to predict them. Anyways, thank you for listening, and I hope you were able to learn something today about hurricanes. See you in the next part. Make sure to follow us on socials for any more weather information. And that's it for me. Bye now.